Hello everyone, welcome to my lecture about the internet. So this topic will be scalable systems. We'll learn fundamentally what is it and in which point it's helping us to understand concept of internet. Okay, the internet began its life as a network connecting universities and research centers. Once it became available and affordable for consumers, it shot up in popularity and is now used by an estimated 4.5 billion people. That's really enough. Yeah, you can check in the years like how it's come up, like how it's growing. It's the first Africa, then it's going up, it's like that. Yeah, you can check it for so when you pause, you can check it. Uh, yeah. Fortunately, the protocols powering the internet and the web were designed for scalability. A scalable system is one that can continue uh, functioning well even as it experiences higher usage. Yeah, internet scalability. Yeah, let's check it. Let's go a little up. Yeah, sorry. Yeah, what features? mm, What features increase the scalability of internet? Yeah, we'll look now positive and negative side, right? Any competing device can send data around the internet if it follows the protocols, right? There is no bureaucratic process that blocks a device from joining or it prevents a programmer from learning how the protocols work, right? Like that. The IPv6 addressing system can uniquely address a trillion times the amount of devices, which is better than IPv4. This is alternative, which is the after IPv4 it's extended, so it's uh, adding a pin there. Yeah, where is it? Right, connected to the internet. Routing is dynamic, so new routers can join a network at any time and help to move data packets around the internet. This is about hierarchy because in all the stuff working in hierarchy. I mean, the internet was designed to be scalable, but not 1 minute. Yeah, the internet was designed to be scalable, but no system is infinity. So I think this point is not more than this, right? Infinity scalable, right? Infinity scalable, but no system is infinitely scalable. What threatens the scalability of the internet, or put another what is that again here? I think it's not long point. Oh yeah, it's long. Yeah, let's bring it down to here. Okay, I think yes. Yeah. What threatens the scalability of the internet, or put another way, what could go wrong if every single device in the world connected to the internet right now and attempt to download a movie? Here are 5 ideas for that. Okay, let's check it. Our topic is here, like our questions. If every connected devices, uh, so single devices in the world connect to the internet right now, what will happen? Like if they download a movie at the same time. Here are 5 ideas. Okay, we can check exactly what is this ideas. Yeah, let's go a little up now. Let's go a little up, right? Network connections have limited bandwidth. A huge amount of data may flow easily through to very high bandwidth connections, but it could easily overwhelm of bandwidth connections leading to delays or dropped packets. Okay, this is one scenario. Routers have limited throughput, the amount of data they can forward per second. A modern consumer router has a throughput around 1 gigabyte per second. Yeah, while much more expensive enterprise routers can forward up to 10 gigabyte per second. An average movie is around 1 to 10 gigabytes. So worldwide download a ton could get bottlenecked in the routers. This is another scenario. Yeah. Wireless routers often have a limitation in the number of devices that can be connected to them. Typically up to 250 devices if everyone tried to use a shared Wi-Fi network at the same time, like in a university or library, they might find themselves simply unable to join. Yeah. So after 250, you cannot join there or in this like in this rate. What is that? Uh, Now, based on everything you learned about the internet, what else might affect its scalability for good or bad, right? Web application scalability. Okay. A web application that runs on top of the internet must also be scalable, whether it's as an iPhone app, a website, or multiplayer game. Now that there are billions of people connected to the internet, an application can suddenly experience a surge in its users. If the application doesn't scale to meet the demand, users might experience increased latency or a complete outage, right? Let's come down what I did. Let's go up. Let's go slowly. During the COVID-19 pandemic, people across the globe were asked to stay indoors to decrease infection. Many of them rushed to online services for virtual versions of what they were missing in person. Due to the many students turning to Khan Academy or any other platforms like Khan Academy, MIT courses, also Coursera and more platform. So has been busy, have been busy. Sorry. Yeah, our website experienced a 250% increase in server load. Oh, this is big, really. Now I will visualize it, demonstrate it with you. Yeah, it is. COVID-19 time. Yeah, it's look how growing up, going up to up. That high usage took our system by surprise, and a few of them were just let's go a little, barely handling the sudden onslaught of requests. For example, our system to notify students about new assignments was getting backlogged. So notifications would take a 5 minutes to show up versus 5 seconds, right? So because the traffic coming up here, let's look, it's going up to up. And for that, you need scalability. You need to prepare before these things. Like just think you want to create application, but you don't know how many people will use it in the future. Like just think like you're thinking like users of application will be will be like 1 million, but yeah, yeah, you made it, like you made it this platform for so for 1 million people, then you see in the server like 3 million people's coming in. You don't have scalability for that, and it will collapse your system, it will collapse your network servers. Fortunately, our engineers quickly bumped up the capacity of those systems, and most users never noticed or anything else. So, yeah, this is the point. This is what I'm saying. It's coming up to up, like here, the system collapsing. Load testing. Yes, engineering teams can prepare for spikes in usage, also spikes in neurons or in synapses. It is like consciousness, something like that. Anyway, let's speak later about it because it's just outputs coming analog. Uh, Load testing. Simulating high amounts of traffic in a short period of time to see if the system buckles under the load. Load testing can uncover, let's close it, uncover bottlenecks or hard-coded limits in the system, yeah, which is everyone is joining. Like you can see, scalability. So just yeah, some demonstration. Let's go down for that, if possible. Yeah. Ever played Pokemon Go? It's a mobile game that came out in the summer of 2016 and was an instant bet. If I have, I will show you. No, I don't have this now. The game developer did load testing before releasing the game, simulating 5 times the highest amount of traffic they expected, and the game servers handled it just fine. They vastly underestimated the popularity of Pokemon Go. However, on launch day, their servers saw 50 times estimated traffic. This is really crazy. Just think, like you're thinking like something will be in this point at this point, but the users coming ton and it's coming up to here, then your system is collapsing, not working good. The game servers weren't ready for that level of extreme load. So many players were greeted with a disappointing screen. Like what? Like that? What it's saying? Our servers are experiencing issues. Please come back later because system collapsed. The team scrambled to improve the scalability of the system amidst growing demand from frustrated users plus multiple DDoS attacks on their servers from cyber criminals also. So also here Pokemon Go saying here like to ensure all trainers can experience Pokemon Go, we continue to add new resources to accommodate everyone. Thank you for your patience. After reconfiguring their server architecture to be more scalable, the team released Pokemon Go to the rest of the world. In the 3 years since it's been downloaded more than 1 billion times from mobile app stores. This is really crazy number. The spectrum of scalability. A system is scalable when it has the capacity to, let's go a little right. Okay. A system is scalable when it has the capacity to accommodate a greater amount of usage. Some systems aren't at all scalable and can only handle exactly the amount of usage they were designed for. Scalable system can handle extra usage, but their capacity varies. Some systems might only scale to handle double to current usage. Other system might scale to handle 1000x the current usage, right? When we are designing system with potentially global reach, such as internet itself or applications, where is that? Right. But run off top of it, we need to always consider the scalability of our approach. Yep. We need to know, like, we need to prepare always our platform for big scalable so for big traffic, like we need to know, like we need to create a platform scalability for all users, because if we didn't solve it before them, if we didn't configure it, then the system will collapse, and then everyone will feel better, so frustrated, they will live frustrated. Scalable system practice questions. Let's start it. Okay, let's look here. I will take my pencil. Let's go a little down. Okay. IPv4 is the first standardized. Let's take it. Okay. IPv4, the first standardized version of the Internet Protocol. And what is that? Oh, what is that? Let's check if there's something. Is there staying? Yeah. Yeah. Let's go. Yes. IPv4 is the first standardized version of the Internet Protocol. IPv4 is gradually being replaced by IPv6, a more scalable version of the protocol. Which feature of IPv4 makes it a less scalable system? Okay, let's discuss it and look which one is true. Okay, IPv4 system can use network address translation to allow a single IP address to represent multiple devices. Typically, a router's IP addresses is used to transfer over the internet, and then router can send data to of the device connected to the used internal IP address. Each IP packet, look another one. Each IP packet header includes optional options fields that can be used by different internet, blah blah blah. You can check it, this is not true. IPv4 includes a checksum field the header to enable routers to make sure the header was not corrupted maliciously or accidentally in transport. Each IPv4 address is a 32-bit number, right? Like what? So the first point, 1 power of the 2 power of the 3 power of 2, 4 power of 2 will be 16. But then, so you need to think 32 for it, okay? Because what we have here, 4. So between 0 and 255, right? So 32-bit number, yes, it's like, yeah, like that. That's enough space for two, like 12 times 10 possible addresses for internet connected computing device, less than the current number of the internet connected devices. Yeah, for that we bring up to for we bring the to the IPv6 alternative, because IPv4 cannot help us for 3 billion or 4 billion peoples. So it can just help us in small pieces of point, like with the small population. Yeah, the this one is the answer. Where is the okay pencil is here. IPv6. This one is true. Let's go down. Yeah. Which description of internet communication is accurate? Like, internet communication. Yeah, it's a cool question. Internet communications are powered by many protocols. One of the most important protocols is the Internet Protocol IP, since it describes both addressing and routing. The protocols add layers of functionality on top of the protocols such as TCP for reliable transmission, right? That's true. The Internet Protocol IP is the protocol responsible for all aspects of the Internet communication. It describes aspects such as addressing, routing, availability, and security. It is continually improved to add new features that are needed for nowadays. So Internet, what have more than it? The Internet Protocol IP is the sole protocol used for Internet communication. It includes rules on message forwarding, addressing, and encryption of data, and requesting from servers. Adding anything onto the protocol would break the Internet. So communications on the Internet still work exactly the way it did back when it was invented. Internet communications use a variety of different protocols. Some types of messages are sent using the Internet Protocol IP. Other messages are sent instead using the format described in the Transmission Control Protocol. TCP, the computer decides between IP or TCP depending on the case. The answer is the A. Internet communications are powered by many protocols. One of the most important protocols is the IPs, as it describes addressing route. Other protocols that layers functionality on top of the protocol, such as yes, this one. Let's go for three. Which of this is where that the internet? Let's go here. Which of this is a way that the internet protocol IP contributes to internet communications? Yeah. It describes mechanism for connecting to competing devices with an Ethernet cable. It describes an addressing scheme to uniquely identify each node on the internet. It describes a way to send email messages to recipient based on their email address. It describes a process for encrypting data between the source and destination. What do you think? It describes an addressing scheme to uniquely identify each node on the internet. It's got a mechanism for connecting to computing device Ethernet cable. It's not. It describes a way to send mail messages to recipient based on their email address. It describes a process for encrypting data between source and destination. IP protocol. IP contributes to internet communications. What do you think? Yeah, just think about it and let's put it here. Yes, what do you think? Which one is the answer? Do you have any idea? This one is not true. It's not about that. This one it describes a way to send. No, it's not. It describes the process for encrypting data. Do you think it can be? What do you think? This one's true? Is that true? I think it's not. But the answer will be here. The B. Okay. This will be our answer. It describes an addressing scheme to uniquely identify each node on the internet. That's all, friends. The next topic will be the Internet Protocol Suite. Okay, let's go up. What we did. Go, 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 go. We did our practice. We solved also our practice questions, problems. Is that all? Yes, this is our all topic. Thank you so much for joining. I hope you'll enjoy with me. You enjoyed with me. Next lecture will be about the protocol suite. I hope you'll be there. Hope you learned more things about scalable system. Just you need to know the the scalable system too much important. This IPv6 more explainable for that. Like IPv6 gives you much more chance to bring there more devices, single devices, or laptop or another computer. It will grow up to scale on the system. Okay. Thank you so much for joining. Have a good time.